broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, Mark Berger. We'll get started here in just a couple of moments with the Heitek webinar. Appreciate you all joining us today. All right, guys, it's 10 o'clock. We'll start on this Heitek automation webinar with Simicode. My name is Mark Berger. I appreciate you taking the time out of your busy day and these circumstances where we're kind of hunkering down. I hope that I can help out with anything with motor management today and maybe provoke some thought, or maybe help with a new project or something old that you're trying to figure out what's going on, and maybe also get you to start thinking about motor management differently. I appreciate your time with us today. I'm very grateful for it. We're going to do a little PowerPoint initially, and then we'll do some hands-on. If there's any questions, I can see questions. I will answer them towards the end of the presentation today. I've set this up for 2 hours. That was me being optimistic that we can have some dialogue and so forth. We probably only go for about an hour, hour and a half, but I'm definitely going to stay on for the 2 hours to answer questions and help out in any way and provide any other information that I may not have given you that you were looking for. Well, let's get started. I sure appreciate it again today for everything. Quickly, an introduction. My name is Mark Berger. I'm with Siemens. I am an applications resource consultant for our controls products group or our electrical products group. I've been with Siemens now rolling up on 15 years. I was initially a salesperson for Siemens covering all of Utah, western Wyoming, and eastern Nevada. I have been in the gold mines, the copper mines, natural gas, Trona mines, and then of course other companies here within Utah. If you haven't figured out, I am stationed out of a little town north of Salt Lake City, Utah, up in Ogden, and I've been born and raised here in Utah. I am excited to be a part of the group that I'm in now, which I've been in for about 3 years. Where we sit is that you have your product, your controls products or electrical products, power supplies, circuit breakers, motor starters, push buttons, anything with the power distribution group, and you have product consultants. I am the product consultant. I'm their technical help. I'm their application assistance. And if anything talks to a PLC, that's where I help bridge the gap. Our product consultants are extremely smart with short circuit ratings and motor sizing and AC1, AC3, different types of aspects of controls. But the PLC side is that's where I help bridge that gap to talk with the PLC. Here's kind of the agenda for today. We're going to, with the agenda, we're going to talk about motor management technology. We're going to focus on control and monitoring and protection of that motor. We're going to introduce the Siemens motor technology that we have to provide, and then we're going to discuss some of the benefits and so forth, and then we'll get into MCC retrofits and dry runs and automatic pump unblocking, and then achieve fail-safe with a motor starter, and then at the end we'll do an OPC UA communications and cloud connectivity. I don't have a cloud. Siemens' product is called MindSphere. I do not have that with me, but I would show you what we need to do to set it up within the Simicode. All right, Simicode. One of the biggest questions I have from everyone is, where did we get the name? Well, Siemens likes putting SI in front of everything. So Simation, Simotion. So we put SI for Siemens, motor, MO, control, CO, device, DE. So that's where Simicode comes from. Siemens Motor Control Device. I really like that name because it does provoke some conversation with people, and that acronym really works out great. In a previous life, I worked for the shuttle boosters, the white rockets that flew the shuttle, and I worked with NASA a lot. And as you well know, the government and NASA have a lot of acronyms, so Siemens has them too, and I kind of fell into that acronym world, and it's been pretty much second nature. Okay, a motor application. We have a motor sitting out there. That's 7.5 horse, 1800 RPM. It might be running a pump, conveyor. It might be doing something that is maybe moving something or helping keep a product cool with fans and so forth. With that in mind, you have 3 aspects of it. You have to protect that motor. Heat and overcurrent is a big enemy to the motor. You want to protect it. You want to keep it running efficiently and properly. Of course, you want to have some PMs on it to where you have to grease the bearings or maintain whatever the motor is connected to, a conveyor belt, a fan, etc. You want to control it. Local e-stops, local control there at the motor, local motor control centers, or then you want remotely to start and stop it so that you're able to do the control system and look over the entire process that motor is a part of maybe conveying systems or pumping systems or stirring systems, etc. So you want to control all that of how long the motor's on, how long it's off, and what its duty cycles are and so forth. And then, of course, you want to monitor. Monitoring is a key thing for motors. The key for that is that motor application, your process engineer is a data hungry person. You can't improve a process unless you measure. And so you can listen to your motor to what's going on. That could be a temperature on some bearings, or it can be vibration with misalignment. It could be many things that we will investigate today with SIMACode. With that in mind, this is where Siemens's motor management system comes into play, is that we cover all three of these aspects: monitor, control, and protect. So there's, first off, let's talk about control. There are many forms of control with a motor. There's a 2-wire, 3-wire, local, remote, forward, reverse, run with permissives, interlocks, handoff auto, and then remote, so forth. So with control, here's just some simple ladder logic and then also a simple control scheme of an HOA. You have right here start and stop, remote mode, and you have the ability to have an overload with the motor. So if something does go wrong in the process and the motor overheats, it'll trip. But here's just some simple common ladder logic for motors, where you have the start-stop circuit, and hand meaning that it's local, remote or off or auto meaning that the PLC is in charge of turning the motor on and off, so forth and so on. With the logic is a cost-effective way of using it. Logic helps you. It's not hardwired. Back in the day, in the early part of the career, I was in a control relay, and if some of you who've been around this world of controls, you definitely can remember the relay panels, the clicking and clacking of just relay logic going on inside that panel. In the I/O, is hardwired. It's hard to change that. It's hard to maneuver if you wanted to do some type of different logic. But with the controllers introduced and ladder logic and other types of programming schemes, it is easier to work on that. One moment, please. Apologize for that. I'm back. All right, so here's the key to this. I apologize. I had an emergency phone call that came through. I apologize. But here's the key to this, guys, is that a lot of this logic is now you can quickly make changes on the fly because of it being software driven, not hardware driven. Whoops, sorry about that. Okay, if we had a panel out there in the field running this motor, here's just kind of an example of the panel where you're wiring in the logic that you have. You have a field bus, you have a push button station, you have some of the simple I/O and so forth that you would have, maybe some remote I/O that brings in some of that logic and execute and repeat common operations. Okay, I've got a simple start stop and then a command. With this in mind, on the logic side now that we're on the software side, we want to look at the logic and see how we can minimize that logic. And what I mean by that is that this simple circuit right here, this is my interlock or my maintain, because this push button might be a momentary push button to start the motor, but you want the motor to continue to run. So you have to have some type of interlock that locks that motor, and it continues to run until somebody press stop. So this is your sealing circuit or your interlock or your maintain contact for that and that logic in that cabinet. Now the reason I'm bringing this up is that I'm going to show that this software is moving to the field in just a minute, and you'll understand a little bit further. But keep in mind about reducing logic in the PLC or the controller. There might be a run permissive about a remote mode, so forth and so on. Okay, so we're looking here as if we have a remote cabinet. We have the main cabinet with the PLC, pilot devices, maybe an HMI, and then maybe 300 feet, we got the pilot devices for a remote cabinet and so forth. And then we have a field bus where we're communicating from that remote cabinet. And you might put logic in that cabinet too. When I started out in this field in the early 90s or late 80s, you had everything in one big gray cabinet. The control, everything was in there. And then remote I/O came out, where you moved the I/O out to the field with a field bus communications, an RS-485 communication protocol, or an RS-232. And so you move the hardware out into the field. But what follows usually is the software goes out to the field after the hardware goes out. And you'll fully understand that just a little bit with Simicode here in just a minute, and I'll show you some things what I mean by that. To allow for easy changeover in logic, it helps to be able to move that out in the field. You're cutting down wiring and terminal blocks and costs and so forth with it. Okay, so here's kind of a traditional full voltage non-reversing handoff auto of the main PLC, the remote cabinet, and the hardware logic. And this could be a motor control center, or this could be just a control cabinet. Okay, hand in position, and then auto. So if we build up kind of a hardwired logic, 300 feet, input, output cards, and so forth, and then maybe we want to have these contactors. Of course, we want a contactor stating that the motor is turning, it's pulled in, the 3-phase, and then you have an overload contactor letting you know that it's the motor's running okay, it's not in an overload state or heating. And then your HOA, so there's an auxiliary contactor there. And then we have, if a customer or a plant's requiring monitoring current, then you're going to have a twisted pair with going into an analog in. Okay, so 3 digital PLC input points, digital PLC output points. This is kind of the bill of materials, associated cable tray, conduit, and so forth. But what do you get for it? What trouble you get into? You can lose an output to turn onto a motor. You can the contactor could close, but the motor's not running. Your HOAs maybe not be working. Some mechanical contacts have gone bad. You know if the overload is tripped or not, and then you can add a motor amperage for data for a price, a big analog card, and then that twisted pair. But understand that these contactors here add another mechanical property to where they have some intermittency, or the contactors can go bad in the field. But here's just kind of an actual scenario of all that wiring that we had in the previous of per motor. And here's all the wiring. Each of this wire that you see in these motor control centers or control cabinets are landing at the buckets, and they are all the data coming from the scheme that you see here with the inputs and outputs and so forth and so on. So with introducing field bus, we remove all this wiring, and the communication is down to one cable itself. Okay. So now we're into the field bus now. So we remove all the multiple wires and hardwired and and landed. Okay, so now we introduce the field bus. Here's the remote I/O, and here comes the same scenario. But now we get rid of all that wiring, and we get rid of the conduit, because now we're bringing in a field bus cable, which could be a Profibus or Profinet, an RS-45 communication protocol, or TCP/IP protocol. So we're reducing that. Okay, what do you get with your trouble of all that you've done? You know the overload. You can add a motor and data, and pretty much about the same thing as if you had hardwired it. Okay, now go from field bus. Now that we move the monitoring out in there, now if you notice, now we've put the remote I/O, we've put logic, motor protection, and remote. We've moved all that out of the PLC, and we've moved it into the cabinet where the motor is, or it could be the bucket. So what we're doing is you're seeing that the controller is now becoming more of a traffic cop, if I could be so bold to say that he's trafficking and monitoring alarms coming from the field in the remote I/O cabinets. This unit is taking care of the remote monitoring, it's taking care of the motor protection. It has flexible logic in it to take care of scenarios that may arise in the field. And then it has remote I/O, and then it has the pilot devices. And anything that goes on with the monitoring, the control, or the protection is reported back to the field bus, to the PLC. What this gives you is that the logic becomes more simpler in the controller, and the controller now is more turning to a traffic cop, or monitoring alarms. And if it has an alarm at a pump, then it says, okay, this remote cabinet says I have an alarm, we have a problem with this pump. Then the controller says, okay, with this pump we have a problem, I need this valve shut, and I want to turn on a parallel system and open up this valve and turn this pump on. So this becomes an alarm handler, or a product handler for it. Okay, so this box of remote cabinet becomes to where we come in to motor management system. And this is where Simicode slides in very easily and provides awesome power for your motor control system. So if we introduce that circuit, and we introduce a Simicode into that circuit of what we showed earlier of the motor, HOA, and stop and start, here's one thing that we are immediately eliminating. We don't need that auxiliary contact saying that the motor's running. This guy can go away, because the Simicode will be automatically monitoring current and seeing that it's going. And then if you did do a momentary push button or a maintain push button, it's just a checkbox in the Simicode, and it will eliminate using that auxiliary contact. Okay. So if you look down here, we're wiring in the stop-start circuit on the Simicode, and we're wiring in the HOA locally to the Simicode. The Simicode has its own 24-volt power supply, so locally within the cabinet we can excitate that stop-start switch and the HOA locally, so we don't need another power supply in the cabinet. And then we're going to remove, again, as I stated, those contactors, the overload contactor and that sealing circuit, or that interlock. That all goes away with the Simicode because it's not required. So now we're reducing more wiring, reducing mechanical failures as contacts, because we're getting rid of 2 of those. All right, now let's move on to monitoring. What's the difference between measuring and monitoring? Local measuring only provides raw data. But if we're monitoring, then it provides analysis of that data. And that is where it separates and comes into a motor management system. Okay, so monitoring consists of 2 parts, the detection and the response. And that's where I was saying is that the local remote, or the Simicode, is doing the detection, it's continuing to monitoring, but then it sends the alarms or sends situations to the controller and says, how do you want me to respond? And that's where the PLC or the controller becomes more of again, an alarm handler and a traffic cop. So detect the event, Maybe it might be a limit switch or voltage sag or swell or overcurrent or undercurrent or a stall or an overload of the motor, or maybe a power factor goes bad or some type of kilowatt per hour limit is reached, or maybe an RTD and a temperature is reached, or a pressure switch, or we've turned the motor on too many times, because we can keep count for that for the monitoring. Okay, so best response equals a trip or warning or a signal. We can, with the remote IO in the field, with the SIMA we can classify how we want that motor management to act and react to events. We can trip the motor, stop the entire process, or we can send a warning to the operator and say, hey, we have a problem in the field, it's approaching a certain level and so forth. Or we can just signal the operator to say, please, when you have a minute, take a look at this and find out if this is okay. Or, hey, we're just letting you know everything's all as well. Okay, so here's just a quick little snippet of the SIMA code showing the fields to where that you can go in and you can pick warn, signal, or in some cases, we can also show trip to where that we can trip the unit. Okay. Well, let's talk about some analogies with the motor management system. What's the analogy? Right now, our cell phones, they do all types of stuff for us. I mean, they're our camera, they're our video recorder, our radio, MP3 player, our calculator, our GPS, our flashlight. Our cell phones are so much to it today. I add one on here is that it's my home security. I have home cameras that are on Wi-Fi, and anywhere I'm at in traveling, I can look in on my house, in my front yard, my backyard, and it becomes my home security access. Well, what about a motor management? What's a comparison to that? If we have a motor management system, what can we provide? Well, with SIMA we can do a tremendous amount. We can do it is a solid state overload. It is your current monitoring relay. It can be a voltage monitoring relay. It can be your power factor relay, a phase monitoring, loss of phase or phase imbalance. Jam protection. It could be your jam protection. Now, if anybody there has been around in the electrical business for quite some time, in Wyoming, I had a customer, and they come to me and said, we can't find this old Westinghouse jam module on eBay. Well, what it was is that it was a reversing contactor, and they didn't care what direction that this motor turned as long as this kept spinning. That's all they cared. And it was a hammer motor application. And so they didn't care if it was spinning clockwise or counterclockwise. But if something jammed up the rotation and wedged in there, they didn't want it to trip. They just wanted it to change direction. And so Westinghouse had an old jam module that you plugged into their overload contactor. And if it saw a current get to a certain point, it stopped clockwise or counterclockwise and reversed the direction that it was going. And that's what they needed. Well, Westinghouse no longer sold it, and they ran out on their eBay supplier, so they were looking to replace this system. SIMA can do that for you. It has a jam protection module in it that is sitting there waiting for you to use. Temperature monitoring. So another application of where Siemens or our SIMA looks at the entire process. Some motor management of some other manufacturers, they're just looking at the overload, turning it on and off, counting maybe how many times it turns on and off, and that's about it, and maybe reporting the current and voltage. But what else we can do is the SIMA we could add on an RTD module and put an RTDs up to 6 and measure temperature on gearboxes, pump housings, pillow block bearings, to where the SIMA becomes not just the motor management and not just a simple smart overload, but it becomes an entire process diagnostic tool to where you can see that, hey, mechanically, maybe these bearings I'm getting some friction and they're heating up, or maybe I'm getting a vibration and I need to bring in a vibration sensor and if this vibration gets up to a certain amount of G's, please trip the motor because now we're maybe misaligned really bad or something other mechanically has gone wrong. So I can go up to 6 RTDs into Simicode. Ground fault relay, I can add additional digital inputs for different types of scenarios of interlocks or bypass or permissives. Analog, I can bring an analog signal in, as I stated, like a vibration sensor, a 4 to 20 milliamp signal. Or with me up here in Utah, I live close to the Idaho border where potatoes are the farming. The Simicode can stand alone. It does not require a PLC to work for any of the stuff that I'm showing you. It can stand alone, and or it can work in conjunction with PLCs and controllers and big discrete automation systems, huge automation systems. It's very powerful that way. But for instance, of my potato farmer that I mentioned, I put a Simicode into my pump panel. And in my pump panel, it's running maybe a pivot system or some type of sprinkling system. Well, with these sprinkling systems, these couplers break or a pipe may burst, and he's spraying and he's not watering the entire field. He's just spraying water out of it, but he doesn't drive by to see that it broke and it's flooding his maybe flooding this one point and washing away his crops, or maybe even worse, flooding his area and flooding his neighbors, the farmer next door to him, and washing away his crops. So we could put a pressure transducer, bring in that 4 to 20 milliamp signal, set up some functioning parameters of the process of what pressure is good for that system and what pressure is bad, where maybe pressure's dropped completely off or it's overpressuring the system. Now I'm not controlling the pressure. I'm turning on the pump and the pump's going and it's working and doing its job. But if I see pressure go without the nominal process parameters, I can have the motor tripped and signal our farmer and let him know that, hey, something went wrong out in the field and I need you to come and look. Maybe a coupler broke. The pressure dropped way below the nominal pressure of a normal operations of that irrigation system. Safety relay with Simicode. I can do SEAL 3 performance level E within a motor control bucket standalone or tied to a control system, an overall control system. Power monitoring, I can do kilowatt per hour. I can do cosine phi, apparent power. Energy meter, I can do an hour meter. I like the hour meter because that one there is a lot of maintain or preventive maintenance on motors and applications are usually a calendar event. And so every 6 months, go out and grease these bearings, check the alignment, check the motor junction box, et cetera, et cetera. But one of the key things to that is that it is important to be able to give a really good metering for that system. And again, sometimes you might go for 6 months and that motor's turned on twice, but you're out there already doing the PM on it. So instead of doing that, how about if we have an accumulative hour meter in the Simicode, and once it hits, let's say, 600 hours, it sends a signal to the operator. The operator fills out a work order, sends it to the scheduler to schedule down that motor, hands it to maintenance. Maintenance goes out, does its PMs on it, comes back to the operator, he resets the hour meter, and we're off and running. So let the motor management system dictate when the PMs are taken care of with the hour meter. And then counters. For instance, I had a process out in Nevada where that motor shouldn't only turn on maybe twice a day, and that's it. It was some processed water, and if it got to a certain level, this pump would turn on and take it down. If it turned on more than 2 times a day, there was something significantly wrong upstream of that process. And so we put in a counter for that motor to turn on, and it sent to the operator saying, this pump is turned on twice in the last hour. Please send somebody out to check on what's going on. And so he was able to call on that and use that again as a process measuring and verifying that everything's going well with the process. Again, I said it is a local system. You can have it not tied to a PLC or a controller. It can run itself all by itself into a pump panel or a standalone application. I have timers built into it for how long. So for instance, on that jam module, when it jammed once, I started a timer, and if it jammed again within 5 minutes and went in the same or reversed the direction again within that 5 minutes, then the machine stopped and sent a signal to the operator to say there is something major going on. But if it didn't jam again after those 5 minutes, then it just reversed and moved on the process. But there's ability to use timers. Signal conditioners, this is where I'd use in conjunction with my analog input for that pressure so that I could show the nominal pressure that's being pumped in that irrigation application I spoke of. Network interfaces. Simicode talks Profinet, Profibus, Modbus RTU, and Ethernet IP. I'll show that in just a few minutes. And those are distinct part numbers for those different network interfaces. And then cloud edge devices. One of the key things here, this is kind of a buzzword with cloud and edge device and so forth. What I want to show in the Simicode is that Simicode comes standard on the Profinet with a OPCUA server built in. And we'll talk a little bit further about that. Okay, starting with the communications and motor management, kind of theory of operation. We bring in all the inputs. We have a command to run, and then we are okay to run because all of our inputs, our interlocks, our permissives are in the right states. And then we turn on the motor. And we send out outputs from the Simicode as an input to the PLC, and then we also send out stuff for the operator panel. This is where the Simicode comes in and where it sits in the motor management for communications. But again, Simicode takes over logic, it monitors, and it protects the system and the motor that it's returning. Compared to a remote I/O solution, how does it compare if we put out some remote I/O? So if we have that field bus and we put out a remote I/O, it adds current. You have more wiring. The local logic is fixed. Protection is limited. Provides measuring, not monitoring, and does not simplify the PLC logic. But if you use this smart motor system, it does simplify PLC logic. It does not provide, and it does not provide any standalone control. What that means is that if this field bus gets cut, the Simicode can continue to run and monitor the system and see if it's healthy and continue to run its last set point that the PLC offered when the field bus was cut, or if the field bus is cut, it can shut down. So this gives you a little bit of small redundancy that if the field bus or this controller goes down, the Simicode can, and its programmable option, continue to run even though that it doesn't see the PLC. And that's some of the pluses with the motor management system. But here with the remote cabinet, with doing the remote I/O style, and if you cut the field bus, of course, that everything stops. Logic goes away because the logic's in the PLC, and all of the remote monitoring and everything stops because there's no communication back to the PLC to say, hey, what do I do if this happens? With the Simicode, I have the logic in it, and I'm able to evaluate it and keep moving with the set points that I have, or I can shut down, and it's all programmable. Okay, motor management system. So here's just some simple applications that we want to walk through just to give you some ideas. So we have our remote I/O, we have our motor starter, and it all wired up. We have a flow, a valve, a filter, another valve, and then we have a tank. Here we protect the overload. Here we're no load operation, direction of rotation, so forth, monitoring the fill levels, the flows, the pressures, so forth and so on. We have no motor information included at all. We don't have current, we don't have voltage, we don't have kilowatt, we don't have no power factor, and so forth. Okay, we introduce the SIMA-code, and now we have that. And we pull in the SIMA-code. We have the temperature module for the maybe the bearings on the pump. We have an analog coming in. We have a filter with a delta P, pressure differential. Then we have some digitals, inputs of the valve opening and closing, and then we have some tank level sensors. And everything is pulled into the SIMA-code with local logic in the SIMA-code reporting back to the controller. So now we do have the monitoring that we need to have. Everything's being processed here. This is not an island of automation. It can be if you wanted it to be, but this automation going on here is being reported back to the PLC. But the SIMA-code itself is running the operations. When maybe it sees a temperature get to a certain point, then it reports back to the PLC and the controller saying, I have a problem, how do you want me to handle it? Or if the analog, if the delta P gets to a certain point, we can just send it up to the operator station and say, hey, we might want to look at this filter. We're getting a delta P across this filter. And then, oh, here's the levels. I'm turning on and off. The SIMA-code would control the pump for filling this, turning it on and off because of the levels sensor that it sees. Or open this valve, so forth and so on. So again, this is where it brings everything local to the SIMA-code, and the controller just becomes, again, a hardware or an alarm manager or a traffic cop to some of the signals that are coming in on problems that may be going in the field. Okay, then we add our safety. We could put an e-stop in here. Again, SIMA-code can do PLC safety with ProfiSafe, or it can do it with a third party using a local safe module, and we can go up to SEAL 3 or performance level E. SIMA-code has been around a while. This is not just a new product. Here's kind of the genealogy of the product. You can see that it started back in 1996 as a Profibus DP. It only spoke Profibus. One key I want to point out with the older system is that that system had an integrated CT in it, meaning that the current transducer, current measuring device was all one piece with it. In 2004, we redesigned it and we separated the measuring devices. So the SIMA-code itself is a standalone system. It has a cable that leaves and goes over to the CT and PT. So you're measuring voltage and current if you like. Either you can do both or just do current only. But what we felt is that you're taking this basic unit, putting it into one side of your cabinet where it's just 120 volt or 24 volts, and then the cables, the CT's going over where the 480 is, and you're keeping that side of the cabinet closed so that you have to just wear your standard PPE. And frankly, with the SIMA-code, there's some digital outputs that eventually over time will fail, that you'll need to replace the SIMA-code. So instead of unwiring all of your motor leads, your T leads, going to the field to pull out the CT when it's integrated, then all you have to do is undo the cable at the bottom, and these terminal blocks are removable. You don't have to unwire anything. Remove it from the DIN rail, put in the new unit, and plug in the terminal blocks, plug in the CT cable, and then download the software to it, the PLC or the logic that's into it, and you're up and running. We'll talk a little further about that in just a few minutes. Again, the safety came out in 2011. Again, SEAL level 3 or performance level E with category stop 1, 0, and 1. And then you have, again, this ability can go with ProfiSafe. If you've worked with Profinet, the ProfiSafe is the safety version of the Profinet, or it can do a standalone with an Ethernet IP, and it will be a safety system with the Ethernet IP. What this is, in kind of plain English, this is our safety evaluation unit, and it works in conjunction with the SIMA-code with a ribbon cable going from bridging from the safety relay or the safety Simicode over to the standard Simicode. Then in 2012, we introduced Profinet, TCP/IP protocol. We brought out a little simpler, more cost-effective one that did current only called ProS. And then in 15, we've got Modbus RTU. And then in 2017, we released Ethernet IP. And then we released another module called ProV-GP, which is called General Purpose. This one here can come with a single port or a dual port switch, but this is a little more cost effective for some more simplistic systems that you might have, to where that you don't need the full arm of a Pro V high feature version. This one will only allow you to expand one either digital or one analog card. It's not as expandable as the standard high feature Profinet, and we'll get into that just a little bit further. Okay, so the Pro S is just only for direct starters and reversing starters. It's very compact. It only speaks Profibus. And then we have the Pro V, and here's some of the components of it, the higher end one. So please understand, you remember I said that our CT PTs are not integrated into the system. It's not all one piece, it's a separate piece. So there's a cable that leaves the CT PT and goes over into the Simicode. That cable can be up to almost 7 feet, 6.5 feet. And we can go up to 630 amps measurement. And then you can see we've added on. Now the basic unit, if you called me today and said, Mark, I've got an application for Simicode, I would ask you for the full load amps of motor, and then I'd ask you for the control voltage. But the parts numbers that I would give today would be 3. The basic unit, meaning the Pro V, what communication protocol you're going to use, the cable that goes from the Simicode out to your measuring device of your CT or PT, and then if you had any other external things that you wanted to add. But the 3 part numbers is what you need for a basic setup of Pro V Simicode. The operator panel is optional. The temperature module is optional. The earth fault module is optional. Analog and digital is optional. Okay. One thing I want to talk about is the operator panel. This is your fluke meter, guys. If we mounted this in a motor control center bucket, and this is on the door, this little operator panel can tell you more than any fluke meter can tell you. If you opened up the MCC door and started, probing inside of it, this will tell you how many times the motor's turned on and off. It could tell you how many times the motor's been running. This will show you up to 20 trips with a time and date stamp. The 21st trip would just be the one that's active. This could tell you how many times or how long the Simicode's been energized, aka the motor bucket's been turned on, versus how long the motor's been running. So there's some key performance indicators. This could also tell you all the faults that go on within the Simicode. And there is some configurable faults that you can do for your own specific processes. And I'm going to show some of that to you today. Notice that this operator panel also has some push buttons on its side, so this can be your local HOA at the motor control center bucket or at the door of your motor control panel. Here's the breakdown of the basic unit. Now, when I'm emphasizing basic unit, that terminology is used in the configuration software TI Portal. So you'll see me say, hey, the basic unit. So the basic unit has 3 relay outputs. Those 3 relay outputs could be for a direct starter, could be for pulling in that coil, and the other 2 outputs could be for maybe doing a lead lag scenario of a compressor or some pump. And the other 2 outputs can be maybe for indicators. So for my little pump panel application for the potato farmer, the one output went to the NEMA contactor for pulling in the pump, and the other 2 outputs were there for pulling in for the light indicators on top of the pump panel. Yellow for saying, hey, you might want to come out here and check things out, and red means I've stopped and something's majorly wrong with his irrigation system. It does have 4 24-volt DC inputs. And if you remember, I said it has its own 24-volt power supply on terminal block 8. I could take this 24-volt power supply and go out and excitate my HOA and my start-stop buttons locally at the motor MCC bucket or the motor control panel. Now, as I stated before, I was a salesman out in Wyoming and out in Nevada, and a lot of the mining applications, they use a 120-volt control system. And so what we would do here, if you came to me with a 120-volt control system versus a 24-volt DC, is that we would add on a digital module that can handle 120 volts. And I'll show that to you in just a moment. Also, in addition, it has a built-in thermistor connection. I know that some of you, with the higher amperage motors, you have a thermistor put into the windings of the motor. It can be landed directly on the SIMCode. And then here's the communication interface. This interface is where we take a ribbon cable from here and then go to the expansion modules for analog, digital, or temperature or earth fault. And then on the Profinet/Ethernet IP version, it has 2-port switches to where you can daisy chain or do star topology or token ring. We can do all types of different communication topologies there with that. Then we have a system interface up underneath is where you plug in the CT or PT-CT combination that you need. And then the SIMCode has 2 flavors, 110 to 240 volt AC or 24 volts DC for excitation of the unit itself. And then last but not least, some of the diagnostics. You have some LEDs to let you know that port 1 and port 2 is plugged in and it's communicating. We have a general fault, and we have device is good and bus is good. And then, of course, this is your solid state relay or overload relay, so it has a reset for it. Okay, so how do we select things with SIMCode? First, the basic unit, BU. Are we going to what protocol we're going to pick? Is it going to be a standalone system? Are we going to do a high-featured one, which has allows you to put 4 or 5 expansion cards onto it? Or are we going to go to a general performance where it only allows you to expand 1 card? And then what type of measuring module? Are we just going to measure current only? Or are we going to measure current and voltage together? That's the 2 things we have to worry about. Those are the 2 main things we have to worry about. Everything else that I speak of is optional. Operator panel is optional. You don't need it. The I/O modules, analog, digital, safety module, earth fault modules, so forth is optional. And then there's some accessories that you can get with it, which we'll show you in a minute. And then there's software. Of course, this is programmable, so it requires software. All right. So again, the part numbers that I speak of here on the right-hand side is a separate part number for each of the communication protocols. And you can see here's the control voltage of 24 volt DC or the 110 to 240. And then this is the high performance, meaning that I'm able to expand 7 expansion modules, extend the control functions. I can use safety on it. Okay. And then the general purpose, I just have Profibus and Profinet. Okay, to where I'm only able to add 1 expandable card. So if you only wanted current measurement and you did 120 volt control and you were going to do just more of a simple current monitoring and motor control, I would lean towards going to the general performance side of things. And then if you were not going to communicate, just going to go from the SIMCode directly to the PLC with no like star topology or anything like that, then I would go with the 1-port version to where it only has 1 Ethernet port. And then if you did 120 volt control, then I would use that 1 expansion module for the 120 volt input, digital input card. So there'd be 4 part numbers that I would quote you. This guy here, the expansion card, the cable, and then the PT-CT, or sorry, just the current transducer for it. Here's the current measuring modules. As I stated, I can go up to 630 amps on it. We start out with the 45 millimeter width. Notice that I can go up here to pass-throughs, okay, all the way up to 200 amps. And then at 20 to 200 amps, I can have a bus connector, and then 63 to 630 amps. Now, I have an application in California that does 800 amps with the Simicode. We have the ability to stage or put a standard CT and make that a primary CT. And then in the Simicode, you check a box to look for the secondary CT, and then you put in the ratio, and I can go up to 800 amp measurement. And what I did with that one is I did an 800 amp measurement with the primary CT, just an off-the-shelf split core CT, and then I put in a 2.4 to 25 amp a PTC or PT or CT for that application here of the Simicode. And then the cables that connect them. Okay. Again, notice I have only current measuring, or I have current and voltage measuring modules. And the big difference is the 3 wires up here at the top, that where you can land the L1, L2, and L3. On the current measuring modules, again, is where I bring in the cables and their lengths. Notice that that cable from the basic unit and routing it out to the PTCT or just current transducer, I can go up to 2.5 meters, which is roughly 3 feet, 3.5 feet. Okay, and that's where we come in here with this guy, is that we're ability to separate the higher voltage where you have to address your PPE because you're opening up a 480 panel, and if you kept the 480 on one side and kept the lower voltages, the 24 and the 120 on another, then you can just wear standard PPE. All right, then the accuracy of these CTs, we're at 1.5% at 200 millisecond update rates. Okay. All right, here's some other options. So the operator panel, we have a one that with no digital to place the Simicode. And when that Simicode's replaced, then you plug in the memory module, you cycle the power, everything's dumped in, and everything's up and running. No software, no laptop, nobody saying, hey, what's the latest and greatest program? Everything is done, you're off and running and off to the races. Now, these little memory modules can be unplugged while it's running. They're not required to stay in the Simicode to keep the Simicode running. So you unplug it, somebody might put it in their pocket and walk off with it. So another customer of ours that uses this recommended we come up with another way of doing it, and we call it the initialization module. Now, what this guy does is that it is interconnected with a new cable. The cable that you use standard is just one point-to-point cable that goes from the basic unit to the CT or CTPT. With this one, there's a different cable that has a Y cable to it. And what it does is this initialization module is mechanically drilled and attached to the motor control bucket so that nobody can pull it out of the front of the Simicode and put it in their pocket and walk away. It is mechanically tied to that motor, or if it's in an MCC bucket, it's mechanically tied to that MCC bucket space. So this customer that pushed us to do this, they always have a size 1, size 2, size 3 spare buckets in their MCC room. And if something goes wrong, maybe the CT control power transformer, CPT, fuses blew or something, and that bucket went down, their maintenance guy walks out there, he racks out that bucket that's gone down, grabs another one and racks it in, and then powers it up. Notice that I puts that bucket in there. I didn't talk about pulling out that memory module. With this initialization module, it's tied to that bucket space. It's sitting in the wireway, mechanically attached with the self-tapping screw. Notice the little eye hole at the top. And so what it does is that as soon as he removed the bucket that had a problem, put in the other spare bucket, all this plugged in, and he cycles the power, it dumps the program into the Simicode, and they're up and running. So that's 2 ways of doing it. The third way is, of course, is having a laptop that you can download the project and just send it to the PLC or send it to the Simicode via the network if that engineering station's tied to the network. So that's the three ways to get the program into the Simicode. Okay, software-wise. Well, I've listed here TI Portal v15. We are up to version 16 now with TI Portal. TI Portal, if you've not worked with it at all, it is our all-inclusive software that programs our PLCs, our HMIs, our drives, our Simicodes, our soft starters, any other field devices that we have like Profinet push buttons and so forth. The reason I didn't put V16 in here is I want to emphasize something. If you have a customer or if you are a customer that already has Simicode software for older versions of Portal, you don't need to buy any license. If you purchase standard, basic, standard, or premium, you can do V16 up to V16 right now and keep that same license, even if it was like maybe version 13 or 14 when you bought it. That license still is good. Now, what has changed, and I want to emphasize, is that with V16, the standard software is going away, and we're just leaving with basic and premium. Basic software is no cost. It is free. You are able to download it off our support website, and you're able to program it via this USB cable. All right? You're able to program it via this USB cable. That is required to program the Simicode with the no-cost software basic. What I recommend is those that do a lot of engineering and multiple motors. And what I mean by that, draw a little line in the sand, is my little buddy up in Idaho with his pump panel. The basic software is probably sufficient for what he needs to use it for. He's going from one pump panel to the next, and they're not really integrated to all the pump panels around there. But I have a customer that's working on a machine that has 30 Simicodes, and it's all networked together. And so I recommend the premium software, which does have a cost, because he can route through the PLC and talk to all of those Simicodes at once. He can do some mass engineering to where if he has 6 size 5s or size 2 starters, he can configure one and mass engineer the other 4 or the other 5. He's able to do access with Profinet. He does not require this cable to program it. He can access it via Ethernet. And this routing is a major way of saving time of walking out in the field and going back and forth from your desk if you have the means to communicate to the PLC from your office. The other one too that I strongly recommend with the premium software is this CFC based. This is a graphical editor. I use this for more of troubleshooting than commissioning. I commission it via the software, but for troubleshooting, this CFC graphical base is very powerful. And I'm going to show that to you here in just a few minutes. All right. One last little guy I want to bring up is this. This is your bulkhead fitting. So let's say I had a customer that was interested in putting all the operator panels on every MCC door. Well, of course, if you've been around a lot of projects, the mechanical guys spent most of the money and the electrical left with whatever the budget was left. So he called me and said, "Hey, Mark, I gotta see if I can tighten up sharpen our pencils or tighten up our waistband on this motor control center. Is there anything you can do to help me on the price with it?" And I said, "Well, do you need the operator panels?" And he said, "No, it's more of a want than a need." I said, "Okay." But I says, "But how about if we don't get rid of all of it? We still give you the functionality of the operator panel." And I'm speaking of this guy, this operator panel here. He had every MCC door had one of those. Well, what he decided to do, what him and I talked about doing, is that I was going to put in this little bulkhead fitting in the door of every MCC bucket. And then he purchased one operator panel. And he put that in a little NEMA 1 box and brought the cable out. And if that MCC bucket, so let's say pump 203 gave him some problems, his maintenance guys would walk out, go into the MCC room, find this little operator panel in this box, walk up to this bulkhead fitting and plug into it and get all the diagnostics they wanted. So he'd only purchased one operator panel instead of, I believe the project was like 35 buckets. And so he was able to still use that functionality, but just buy one operator panel and use it for all of the 35 buckets instead of having one for every bucket. And we were able to save a little cost on his motor control center. This is a great little tool if you just want to get into there and program too without opening the MCC and using with this cable in conjunction, and not open the MCC bucket and worry about your PPE and wear your standard PPE, your hard hat and safety glasses and safety shoes, etc. Okay, configuring it in Portal. So the software for configuring the Simicode is in TIA Portal, totally integrated portal. Totally integrated automation portal. If you haven't worked with Portal, and I apologize if some of you have worked with it, I might be redundant in some of this stuff, but if you haven't worked with Portal yet, if I say to you Microsoft Office or Office 365, what comes to your mind? For me, it comes to mind, I say that, and I think of, well, of course, Bill Gates and how much money he's worth, but then what comes to my mind is Excel, Word, PowerPoint. Well, when I say TIA Portal to you guys, this should now provoke thoughts of, oh, this is my PLC programming environment. This is my HMI programming environment. This is my drives programming and commissioning environment. This is my soft starter commissioning and programming environment. This is my Simicode programming and commissioning environment. So with that in mind, I'm going to stop here at the PowerPoint, and we're going to go to the environment, programming environment.
Where are?
All right, we're getting some. We're getting some.
I don't see tabs.
So you see on the little, it's on the top. You have sharing what.
Okay, we're back. Sorry about that. We had somebody that was stepping over the top of us on that. Okay, so what I'm going to do is stop using the PowerPoint right now, and I'm going to go to the programming environment, TI portal. With the TIA portal, within here in the TIA portal, when it opens up, you're able to go in here and create a new project, open up existing project, migrate a project, and this is for another day. But there was a different piece of software that programmed Simicodes. It was called Simicode ES 2007. If you do have those at your plant, and I'm assuming that we may have some people here that have some of them, and they have maybe the older software. Like I said, the Simicodes have been around since 1996. That software you can migrate that project out of the older software and bring it in here to be a project in TI Portal via migration. And that, if you'll get back to Heitek, I would love to do a webinar for that and show you guys how to do it. That one would be only about 30 minutes long because it's extremely quick and very powerful to do that. Welcome Tour, if you're hooked to the internet and you click on Welcome Tour, it takes you out to our internet site, and it brings you to the videos, so that you can, if you don't use it, you lose it. And so, as a controls engineer, one day I'm working just totally, my brain's wrapped around pressure transducers and thermocouples, and I'm not thinking about with the shuttle booster rockets, I wasn't thinking about the flight termination unit or anything like that. And sometimes I had to get reacquainted with things that I needed to remember. So I've been programming PLCs all day long with ladder logic or function block or maybe STL or SCL, and I forgot about how to do some things in the HMI. So this is a great area and a great resource to be able to go in and just knock off the rust or introduce you to the way Portal works. So, and then installed software. Now, this is where I said that analogy when I used the analogy of Microsoft Office, when I said Excel, Word, PowerPoint, so on and so forth. This is it. This is the TI Portal environment. And in my TI Portal environment, here is my PLCs. Here's my drives. Here's more of the PLC side, and that means I have Energy Suite and I have safety, so I can do safety PLCs. And then here is the software add-on for Simicode. All right, and I have that in here. And then here's my graphical stuff. Now, let me be very specific. Let's say that you are using Rockwell and you're talking Ethernet IP and you really like Simicode and you want to use the Ethernet API version. You will just install Simicode software, period. That's all you'll need. You won't need all this other stuff. And you could use the basic software, which is no cost. And the key to this is that no matter what you have under the hood of, when I say TIA portal, this software here, you when you buy it or you download it free for Simicode, it looks the same, feels the same. Everything is exactly the same if you were programming a drive versus programming a Simicode versus programming an HMI. That's the power of TIA portal. This is the window to that database of your project. Now, I am, like I says, I'm a little new, or not new, but I've been around with the TI portal. And some of you who are new might come right here and hit create a project and so forth. But I'm not new. I usually default to this screen, which is called the project view. With the project view, over here on the left-hand side, this is your project. This is everything hardware-wise, software-wise that you are going to be using in your project. So I could have 15 PLCs and 5 Simicodes and 2 drives and 3 HMIs, and this could be my entire production facility. You can have that in one project. And I have a customer that does that. That's his methodology. He likes that. It's his comfy blanket. It's his whoopee. He makes him feel comfortable that he can open up one project and see his entire plant on the left-hand side and be able to reach out and talk to any of those PLCs or HMIs or drives or Simicodes or soft starters, so on and so forth. Other customers, they prefer to make it one PLC and whatever talks to that PLC. So it may be one PLC with 2 HMIs and 4 drives and 2 Simicodes and 1 soft starter. And so that's their project. Their project parameters is it's a PLC makes a project. But understand the power of this is that if you have the entire plant and you needed to share data from maybe, let's say, the machine A who feeds into machine B, and you needed to say, hey, I need to know how many parts are coming out per minute, and you need to feed it into machine B so that you can accept 15 parts per minute, then this is the ability. It's just a tag that you drag across into the other PLC and the communications that are established. So this is a very, very powerful tool. Across the top, it looks very close to just your standard windows. You got your new, you got your open, save, you got your cut, your paste. My big tools here is undo, and then you have compile, download, and upload, and then some simulation icons, go online. For those who are a little more familiar with the Rockwell world, this is my RS links, accessible devices, or right down here, I can go here and I can go, this is, and pick what's online, what's out there. I'm going on my my NIC card in my laptop. I'm going to hit update accessible devices. It's going to go out and look and find that I have a PLC out there and a Simicode out there, okay, for today's operations or demonstrations. Here's my PLC that I have out there. Right now, due to time, I pulled it in already and we set it up in this network. So here's my network. This is the area that you work on. This is your work area. Down below, I like, because these get real busy, this is all your cross-reference, your compile. If I clicked on this guy and I go into device view, then here's all my properties of the CPU, and here's everything down below. If I'm not doing that, my preference, I like collapsing that automatically. If I'm not using it, it goes away so that I can look at it. Over here on the left-hand or right-hand side, I have the hardware catalog, online tools, tasks, libraries, and add-ons, and so forth. If I go to my network view, it shows you all the hardware. This is the hardware catalog where I can drag and drop things out. And then if I go in and add new devices, or let's say that if I go into, I'm going to go in and program, I'm going to hit main, and I'm going to go program a quick stop start circuit or something. Then once I go into the programming environment, Then notice that here's all my bit operations. My normally open contact, my normally close. Here's all my extended instructions, so forth and so on. Okay? We'll talk about libraries here in just a minute. But right now, I'm going to show you quickly. If you had a Simicode out in the field already, and I showed you I had one sitting down here that's already programmed, you came into a Simicode and you needed to hurry and talk to it, but you didn't have the program. What you would do initially is create your own program, your own project, which I've named mine Project 24, and I want to go out and find out what's out in the field. So then what I'm going to do is I'm going to click on Add New Device. I'm going to go to Online, and I'm going to come down here and say Upload Device as New Station, because I know the Simicode's been programmed, it's working, everything's great, but I don't have the project. So I'm going to hit Upload Device. It's going to say, hey, I'm going to go out via your NIC card. I'm going to say Start Search. It found a CPU out there, and it found a Simicode. So I'm going to pick the Simicode that I want to add, and I'm going to say Upload. And now it's pulling that Simicode, it's pulling the software, it's pulling the hardware, it's pulling everything that this Simicode has in the field. And now if you notice right here on my left-hand side of my project, it's added it. So now I'm going to go to Devices and Networks, and there's my Simicode. It's populated the hardware config, and this is everything that my Simicode has in the facility. I'm going to zoom in a little bit so you can see it a little better. There we go. Zoom out just a hair. Okay, so here's a PT-CT my Simicode has. So I'm measuring L1, L2, and L3. It's a 0.3 to 4 amp current transducer. Here's my basic unit. It's Profinet. And then I added on a digital module for some additional I/O. And then if I go over here, real quick, here's my operator panel. And that's what my demo is. Now, if I wanted to add on another one, I could go here and say, I'm going to add on another digital module, and that's just drag and drop. Or if I needed to replace this and say, I'm only going to do current module, then I would click on it and just say change device. And then I would go pick and say, I'm going to do current measurement only. So I drop that down, and then I pick the current measuring, and it will replace it automatically. Okay, that's if I was looking at it in the field and it's already been programmed. Now let's say that we're starting from scratch. So I'm going to go back to Network View, and I'm going to click here, and I'm going to delete that out of my project. And now I'm going to add, let's say now I've got my PLC, it's all ready to go, and it's eager to start moving on with the next project, and I've got a Simicode I want to add. I could come over here and start dragging and dropping things in here. But with the power of Portal and that add-on module for Simicode, I can come here and say Add New Device. It opens up this Add New Device catalog. And I like this a lot because then it compartmentalizes all the different things that you could add on to a project. Controllers. Here's all my PLC controllers. Nope, don't. And then here's my HMIs. And this is by me, it's just Mark Berger's way. This is my little postage stamps. So I click on these little postage stamps. Here's my HMIs. Here's my SCADA systems, my PC systems, soft PLCs. Here's my drives. And then here's my Simicode. Now notice I said that I can go in here and I can communicate with my soft starters, and I can do with Simicodes under control devices. So now I'm going to go in. Go down to Simicode Pro, basic unit, and then again, here's the different Simicodes that we have. There's Ethernet IP, Profinet general purpose, Profinet, which is the high performance or high feature, Modbus RTU, and then Pro-V, this one's Profibus, this one's Profinet. So I'm going to pick Profinet. Kind of gives you a description what you selected. And if you needed to, if you had an older one that's been sitting on the shelf for a couple of years and you needed to, you could go in and change the firmware to it, but I'm going to go with 2.1 because I've got the latest and greatest, and I'm going to hit OK. Now notice this Start Device Wizard. I highly recommend, if you haven't worked with Simicode much, I still use it, even though that I've worked with Simicode a tremendous amount. I still like it. It's a preference. It's the way I like doing it. We're going to hit OK. Now, what's going to happen here is that the Simicode, I'll be very frank with you guys. Simicode can, as everything I'm going to show you, it can be a kind of overwhelming sometimes because it's very powerful. And so a lot of people think, as soon as they think powerful, they think complex. Well, what we're trying to do is get rid of some of that complexity for you. We want to show you quickly, let the software program it for you. So what we're going to do now is I am going to start the parameter wizard. I always click here on that. And then you can come in here, and here is standard templates of how you're going to apply the Simicode in your project. For my case today, I'm going to use it as a reversing starter. But notice that I have in here, here's the safety side, where I have digital module safety local, meaning it doesn't matter what communication protocol I'm using, RTU, Ethernet IP, Profinet, Profibus, or I do have ProfiSafe, which is in conjunction with Profinet. But I can do safety here. But for today's purpose, I'm going to do reverse starter. And what I'm going to do now, when it hits finish, it's going to go off and the software is going to start installing a template for a reverse starter in the Simicode parameters so that it has a standardized way to wire up the Simicode and a standardized way how it acts and reacts to local, remote, forward, reverse, stop, etc. Okay? And you'll see here in just a minute that part of it. So now the first out of the gate with the startup template, it asks about the field bus interface. For today's communications, this is another discussion for another day, and I'd be glad to have with anybody who's interested. Please get with Heitek and have them arrange a moment of time with me to talk to you guys about it a little further. Just for plain sakes and for the proceed on this is that this is the amount of data that we send to the PLC cyclically. If you're a Rockwell user, it would be the intrinsic data, the size of the intrinsic. For us, it's cyclic, and then there is acyclic or extrinsic, or intrinsic and extrinsic. I apologize, I'm murdering it. That's not it. But anyway, this is cyclic and acyclic data for us. So this is the size of data that we're going to send to the Simicode cyclically. I'm going to hit next. You remember that initialization module that I talked about, that where it's mechanically tied to the MCC bucket? If you're going to use that, you would check the box here, or if you were going to use the thermistor inside capabilities of the Simicode, you would check the box here. For our purposes, no. And then you remember my buddy, I said about he had that MCC bucket or MCC project where he had 35 buckets, and he wanted to use one of the operator panels instead of buying 35 of them per bucket. So what we did here is we clicked no. We said configuration error due to missing operator panel. Just say no, because then when he unplugged that little operator panel and put it away, and all the Simicodes didn't have it plugged in, it didn't fault. But for my purpose, I have an operator panel. If I unplug it, I want it to fault. Then again, it's asking, you sure you want to do reversing starter? And you'll learn that with Siemens software. It's like, are you sure? Are you really sure? So just giving you a chance to verify. Hit next. Okay, now this is where I put in the full load amps. So for my little demo, I'm going to put in 0.5. That comes off the nameplate of the motor. Full load amps. Okay, and then trip class. I can pick a trip class right here. So with the trip class, please understand, and for those who maybe not know what this is, here's my book of Burger, how I explain it to people. I had a buddy of mine. He had a Ford. It always got stuck, and he always called me to come and help him push it out. When do you push the hardest? Bear in mind, you're hoping that he's taking his foot off the brake, he's put it in neutral, and he's not messing with you. But when do you push the hardest? Well, you push the hardest right at the beginning to overcome the inertia of his fat butt sitting in the seat of the truck yelling push, the gearbox, the mud that he's in. It's kind of got a vacuum sucking the truck in, of pushing that truck and getting it moving. You push the hardest. Once the truck is starting to move, then you don't have to push so hard. So that's the same way electrically. On a motor, to get it to turn, you got to give it current, a voltage, of course, but you give it current. So what this does is that this trip class takes the overload and turns it to kind of a deaf ear and turns itself off for 20 seconds. So if I go to trip class 20, then that means for 20 seconds, and again, this is just rule of thumb, the overload turns a deaf ear, allows that inrush current of maybe 115, 350% inrush to overcome the mechanical inertia of the system that you're trying to turn, pump, fan, conveyor belt. If you're at a rock crusher facility and you got a fully loaded conveyor belt, you might bump that sucker down to trip class 40 because the operator was in a hurry to get home and he failed to run the conveyor belt out and empty it out. So you got a huge amount of inertia to get moving. So you turn it to trip class 40. But for my case, I'm going to go to trip class 20. So that's what trip class is. There's a lot more into it. I'm just kind of giving you the quick rule of thumb type case. All right, cooling down period. Because it is a solid state overload, it requires cool down, but nothing like the old style starters. The non-solid state overloads were heaters. They were bimetallic metal heaters. And what it was two dissimilar metals, and as the current flowed through them, they started to heat up. And both of them had different styles of thermal expansion. So it would take and trip maybe differently to where that it would curl away and trip that motor. But then what it would sit is that it needed a cool down period for those heaters to cool off. And so what it would do is that it would, take 300 seconds for them to cool off before the motor could start again. So in here we can simulate a NEMA starter with thermal bimetallic heaters. We can put in here, let it cool down and let it go for 600 seconds if I wanted to. Notice that I can go in here and hold on this guy and we can go down the cooling down period. We can make it up to minutes. 65,530 or 6,553.5 seconds. So, default setting is 300 seconds. So it could be a long time for that. Okay, unbalanced protection. So phase loss, phase imbalance, so forth. Stalled rotor. Now notice everything's deactivated, okay? Or it is deactivated, but it's an option waiting for you that you need to use it. All right, I'm going to hit next. Okay, now here's some of that logic that we talked about earlier when we said about PLCs and having remote I/O. Here are some of the software logic. Let me emphasize this. On the software logic, let's say that we are having a pump and it has a certain amount of pressure, 50 psi, and it's running. Everything's going great. Well, in the PLC, you could have a high and a high and a low and a low, meaning, okay, at high, my pressure's jumped up 10 psi, so I'm up to 60%. So it's still okay. It's within the normal nominal process set points, but it's getting kind of high, something maybe the operator needs to keep an eye on. But then if it goes past the high, then it's a high, then there's something going wrong. Now we're getting up into 70, 80 psi. The flanges are not rated for that, or the hoses are not rated for that. That's where the operator's saying, woo, we got a problem, let's maybe shut this off, or let's call somebody and ask, hey, what's going on? And that's where you set those into the PLC. I can do that in the SIMA code. I can set up those lows, highs, and put that in there and put that logic in the SIMA code as quickly as saying at this percentage of 85% or 84, sorry, and I can go at 72. Whoops, sorry, fat fingered it. And then I can set this, okay, if it hits 84% of the full load amps, then I'm going to trip or signal. Or if I get to 70, I'm going to do warn. So here's where I can go in and do that high and that low inside the SIMA code. And you remember I said if the industrial communication protocol, the Ethernet IP or the RS-45 communication Profibus or Modbus RTU, it gets cut, I could still let the SIMA code run because it can monitor here and take care of it if something goes wrong within the process, because this PLC is not making the decision. The SIMA code's making the decision and just reporting back to the PLC to say, hey, do you want me to run or not? And if this PLC is gone and its communication protocol has been cut, then it can say, "Yep, I'm going to stop." So here's just a little level of redundancy there. We're going to leave that alone for today's application. Motor operating hours. You remember I said about doing PMs? Here's where I would put in 600 hours. And then I would say I want a signal. I don't need to warn anybody. I just need you to signal the operator, let them know that that motor accumulatively has ran for 600 hours. And we're not going to do that today. Notice it's deactivated. All these settings are sitting there dormant right now, waiting for you to use them. You don't need to turn them on. They're just sitting there dormant. Just know that they're active, or they're there for you to activate them. Internal ground fault, that's pretty self-explanatory. We'll move on. Now I finished. So now I put the SIMA code in. All right. So now I'm going to communicate it to that PLC. So I'm going to click here. I'm going to drag it over here, and I'm going to drop it on there and say, "Yep, I want you to talk to this PLC." It's created the PLC communications. Now, what is the IP addresses? Notice that the SIMA code .1. I need to go change this guy just because I know that I want it changed. I'm going to go here, and I'm going to go .20 on that one. So here's the IP address, and I just changed it. Now you could change it here, or I could click here, and take me to here on the properties of it. Bring that up. Do it again. And if I click on the port, it brings up, and there it is there. Okay. And then I can go to the Generals tab, so forth and so on. Now, some of these other settings, media redundancy, this is for another topic for another day, but this is more of your token ring and your star topology type communications. Okay, so now that it is set up in my system, I want to talk further about is the device setup itself. When it went in to, and I told it that it was going to be a reversing pumping application, it put in the hardware config of just exactly what I needed. I gave it the full load amps, so it put in current transducer only for 0.3 to 3 amps, because that's within the specifications of my full load amps of my motor, and it gave me a basic unit. That's it. That's all it gave me. Well, my demo has voltage measurements, so I'm going to click here, right click and say change device, and I'm going to put in the voltage measurement that I want, and I'm going to go grab 0.3 to 4 amp, and I'm going to hit OK. So now it's going to exchange that and put in my voltage. There's L1, L2, and L3 to land my voltage measurement. The basic unit's still the same that I want, but now I want to add my digital module. So I come over here to my hardware catalog. I go to digital modules, mono. Now the difference here, mono versus bistable. Mono means that it is a contactor. If it's a normally open contactor, then you put in a normally open contactor. It is energized closed, but somebody takes the power away, then it returns to its normally open state when the power comes back. The bistable digital module means it has retentive memory. If it's a normally open contact, energized closed, but then the power goes away, but it comes back, it returns to the state that the state that contactor was at. If it was closed, even though it's a normally open contact, if it was closed, it returns to that closed state. It retains its memory of where it was at. It has a retentive memory in it. Now, some people kind of freak out about that because they don't want some machine to just jump and start going. But I do have applications with remote well sites that nobody's within it except antelope and jackrabbits. They do want the system to start back up and run. But for my case, I'm going to do mono. Then also, I'm going to scroll over here. It defaults putting in the non-display operator panel. I'm going to right click and say change device. I could just delete that if I didn't want an operator panel. And I'm going to go to, whoops, go to this guy right there. Sorry. And hit OK. Changes that out. And now I have all my hardware done. I'm ready to download. And I'm ready to download and start turning on my motor. But one last thing I want to point out before I do that. I'm going to go over here to parameters. So it kind of acts like a drive. It has parameters and commissioning if you've done a Siemens drive. And then I'm going to go to Profinet parameters. Here's another place to change the IP address. But I'm going to scroll down and let me emphasize this with the Profinet version. Here is the OPCUA and the web server. Simicode Pro V and Ethernet IP has a web server. The Profinet has OPCUA server built in. And we'll talk about this. This is the connection to the cloud. This is where we would reach out to a historian and so forth. With the cloud is this OPCUA server. And then a web server is the means to be able to type in the IP address and look directly at the Simicode and figure out what's going on with it without any software, without even plugging in. All you needed is the IP address and be on the network with that Simicode. And I'm going to demonstrate that in just a few minutes. That's it. I'm done. I'm going to do a quick take focus on that, do a quick compile, make sure everything's okay. I'm going to download it to the PLC. Start search. Hit load. Okay. It's going to load that configuration into the Simicode. Take just a minute. Now, what else is that's going on in here when I'm downloading this is that I'm also making the connections to the PLC. So I'm going to go to the PLC. I'm going to compile that guy. And then I'm going to download to the PLC. Just to let it know that everything's there. It's kind of a comfy blanket. Hit load. It's going to put the PLC in stop because I am adding hardware. That is always the case to stop the PLC. And now it's going to start it back up and run. And now everything's ready. It's happy. The Simicode is ready to talk to the PLC and so forth. Now, while it's finishing up loading that, let's talk about a story of mine. So I had 35 motors that I had to do for a project back in 2000. And my boss came to me and said, hey, what do we do for that time of getting all of the tags ready for the PLC for that motor? I says, well, I got to start now getting an Excel spreadsheet out, and I need to get some of that tags. I'm getting some of the tags like current limits, voltage, cosine, stuff like that that I was hardwiring into my project. And I need to get those tags. Come on. I need to get those tags into my PLC. So like for instance, if I wanted to get the voltage measurement into my PLC or the current limits, I would have to go into my PLC tag data table. Whoops, sorry. And right now the only tags I have in that is some clock stuff, but I don't have anything in here for my tag, for my Simicode. Well, how do I do that? Well, I could sit here, type that all in. But today I want to show you a great tool with the Simicode. I'm going to click here on the Simicode, go to my Properties, General tab, and then I'm going to come down here to I/O addresses. Okay, so that you know that I'm not anything up this sleeve, I'm going to detach my PLC tag table. I'm going to set it right over here. I'm going to go back to my Simicode. Whoops, sorry about that. And at I/O addressing, I'm going to say create I/O tags automatically. So I'm going to hit create, and look what it did automatically. It created the tags for my Simicode for on, off, or this could be clockwise, counterclockwise, forward, reverse, my overload, my interlock time, remote mode, meaning is the PLC in charge or is somebody locally running the pump, or group fault, or group warning. or max current. So I've got all these tags already created. All I did is check that box and I'm done. Now what happens if I need to add some more to those tags? Or Mark, you ask me, hey, where do these tags come from? So I'm going to go here to my Simicode. Oops. Sorry about that. Control device. And I'm going to go here and I'm going to go to outputs and I'm going to go to cyclic send. So it automatically sends and creates tags. So if you notice, bit 0.0, so bit 0 is forward or reverse. If you come right here, look, there it is, the tag. So what it did is it sends all these tags that were in the template for reversing starter, reverse starter, and defaulted these tags. And when I said create IO tags, it went right to the PLC and created those tags. Well, let's say that I want to add, I'm going to lower this down here. Let me pull that over just a little bit. And I want to add another tag. So I come here and I want to do, let's say, monitoring functions. And you remember I said operations. Let's say that the motor operating hours, it reached the 600 and I want a tag to turn on to let me know that that motor is run for 600 hours. So I click here, checkbox, I just put it in and the tag automatically gets populated into the tag table. There it is, event motor operating hours, and it's input 83.0. That tag gets automatically put in. Pretty slick. I think that is a huge time savings, and it's the ability to be able to get your program up and running quicker and be able to reduce engineering time for it. Now there's a little bit more power to this, I'll show in just a few minutes, but this is a huge time saver for automatic tag generation. Now just a little step away from Simicodes, our soft starters does the same exact thing, just FYI. Okay, so I'm going to minimize, attach that, whoops, go back here, and now I'm going to go back to my Simicode. So those tags have been created. I'm ready now to go in and start programming. So I go into main OB, and I could go in here and add, I'm going to just create a push button, PB start, and grab a PB stop, and then I could go here and I could put in motor. Now I don't remember what the tag name is, so I just can't leave it blank and the tags automatically pull up. So I could scroll down here and look for motor on or interlock, and here's off or here's on. I could drag that over and I want this one to go clockwise, and that's what I hit for that one. And there we have device. Well, that's status. So that's an input. I apologize, I grabbed the wrong thing. So let's go back here. I don't want the status, I want the actual bit that turns it on. I apologize. Let me click on here. Oh, I need to give it a name. So I'm going to say motor 1. All right. And then those tags are in there for that. And then I'm going to go grab the PLC tag. Let's show them all. And again, I've done the inputs, but it didn't do the outputs. So now where I go to do the outputs, I come here, double click here, and I go to IO tags. There's the IO tags for the inputs that's already been created. Now I need to go here, and I know that this first tag is motor forward. Okay, and then I know the next tag is motor reverse. Okay, so now I'm going to go back to my logic. I apologize, I forgot that step. Now I'll go here, motor, and there's forward. And I'm done. So my PB start, I could come here, and I can define that tag, and I could call that just input 0.0. And go right here, PB stop, find that tag and call that input 0.1. And now I have my setup. Now notice I don't have that interlock that I need. I don't need that interlock anymore. Because if I go over here to the Simicode parameters, and I go to motor control and control function, right here, all I do is non-maintained command mode, meaning if I check this box, that means I have to hold the button down to keep the motor running in local. Or if I uncheck it, then that means that I just push the button and it continues to run. Okay? All right, we're rolling up on time. We're getting run out. I hope this has helped out a little bit, but I wanted to show you the cloud communication protocol or cloud communications. So with these on the Simicode, when we did the parameters, I turned on the cloud or OPCUA to where it can communicate to a cloud or communicate to a historian. Well, I want to demonstrate that quickly. So what I'm going to do is that the Simicode is an OPCUA server. OPC requires a client. So I have some software on my laptop that's called, and let me get to my desktop, and it's called UA Expert. And let me open that up. This is an OPCUA client. So I'm going to go to servers, right click, hit add. And if you remember on my software, my Simicode was 192.168.0.20. So I'm going to go here. I'm going to say, hey, I need you to go look at that address and look for an OPCUA server. And there it is. It found it. Okay. And I'm not going to do any type of security other than just a standard certificate. And I'm going to hit OK. It's sitting there. You have to connect to it. So I'm going to say connect. Then it brings up the certificate. Do you trust what I'm connecting to do and say what it is? Yes, I accept. I hit continue. Once that's done, it's made the connections to this OPCUA client. This could be a historian. This could be a cloud server. This could be another PLC of a different manufacturer that talks OPCUA. Because if I go to Siemens and I go to my PLC here, our PLCs have OPCUA client and server capabilities. Here's the server and here's the client. So I can talk to my PLC not just via Profinet, but also I can talk via OPCUA. I come back to this software and I can come in here and now I can grab any tag I wanted. So let's go measured values. And notice I didn't create any tags to fill this, populate this. This is automatically done with OPCUA. So I'm grabbing currents, dropping that down. Notice that I grabbed a float, which is going to give me actual current readings, and then the other two are going to give me percentage. Start my Simicode, and now it's running at 93, 94% of full load amps. Turn the current down on my demo, and now we're down to 60% or 0.29 amps. All this data, and you can come in here and you can monitor the items, and you can also set it the scan rate of how much do you want to save it in your historian. It's that quick and that easy. Okay? All right, next item I want to bring up is that I'm going to now open up the web page to the Simicode. And there's the web page for the Simicode. Your maintenance guys don't need really any software once it's commissioned. All they need is the web page and have access to the network that the Simicode's on. Now this is for Profinet Simicode and Ethernet IP Simicode. Notice that my Simicode's running. I can detect what phase it is. I can't change it, but I can detect. My device is okay, current's flowing, and I'm going, it's all relative. We're going reverse or forward, whatever that is. Here's my faults. Execution on command, meaning I told it to turn on, but I didn't see any current flowing. So it could give you a quick bump to say, hey, I didn't see any current flowing, so something's wrong. The contactor didn't pull in. or execution stop command. I had the motor running, I told it to stop, but current kept flowing, which means in my mind, logically is that one of my contactors welded shut. Now this is a big deal for a customer of mine in Wyoming because their maintenance shop to their furthest motor is a mile away. And by the time the operator calls and says, hey, I tried to turn this pump off, I still see current flowing. By the time they got out there to turn the bucket off, it pretty much just burned up the motor because it was single phase in it, and it was time to go get a new motor or get it rebuilt. So what we could do here is if an execution stop command happens in this PLC or in the SIMA code, I could take one of my outputs and turn it to a shunt trip and flip off the breaker and take the power away. Just a thought. We'll come back to these external faults as the last little item before we call it a day. I sure appreciate you guys being with me today. Measured values. Here's the measured values of SIMA code. Okay, here's my voltage, here's my current, here's my kilowatt per hour, or my kilowatt, my kVA. Okay, if I had temperature modules, this would be reading those temperatures. My analog inputs, I don't have anything. Here's my maintenance and statistical data. Here's some key performance indicators of my motor. My motor is run for 2 hours. That could be that 600-hour set point that when this motor runs for 600, I send the signal for a new PM. It's done 131 starts in those 2 hours. I've had one overload trip. Stop time. I haven't stopped more than an hour. Energy consumed, kilowatt per hour. My device has been sitting there, meaning the SIMA code's been powered up 9,852 hours. Okay, and I've changed its parameters 51 times. Now this something might get some plant manager or some process guy a little worried when you see once you commission a pump and get it running, you should only see parameters change maybe 2 or 3 times just for some specific changes. Or maybe you changed out a motor that went from a standard motor to a high efficiency and you had to change out the full load amps. So you should only see just a handful of parameter changes. Man, if you got 51, there's something seriously wrong in your process. But you can tell and get some data from that. And then you remember the 20 trips. Here's my error buffer. And this is all accessible to your maintenance guy via the IP address or the IP address webpage. Here's all my 21 trips, date and time stamped. Okay. All right. Now let's go back to faults and warnings. And this is my last thing that I'll show you and we'll call it a day. Did you guys know that your little web page publishers see these external faults? Let's say that I did put in a RTD card and I had it on a pump housing and I'm monitoring the temperature or the bearing, a pillow block bearing. Well, how do I tell that and communicate that to the operator that that's what's giving the fault? Well, it comes as external fault. Well, okay, what is it? Unless you have this Orphan Annie decoder ring to tell you what that means, they have no idea. Well, let's go in. Stopping my demo. And let's go to the SIMA code. Okay, and we're going to go to parameters. I'm going to go pick standard functions and I'm going to go to external faults. And let's just say for time constraints, I set this up as a RTD temperature fault. So I'm going to go RTD fault. And I'm going to put it right there in marking. Download that to my SIMA code. Hit load. Okay. Let that finish. Just takes a second. And what I'm going to do now, and once it gets there, now I've disconnected my server because of that it was downloading to the PLC. Okay, so now I got to go reconnect. Disconnect, connect, continue. Now I go to these tags and I go to diagnostics and I go to events. Notice as I scroll down here, notice external fault 1 is missing. Now if I go down here and I go alphabetically, M's, N's, P's, RTD fault, drop that in there. There is that marking that I put right here. RTD fault. Now if I go to my web page and I refresh the screen, RTD fault. So you guys are a little web page and OPC-UA tag publisher with it. It automatically updates and gives you those external faults. Now bear in mind that there is some character, it only allows you to give you 10 characters. You can't put in some elaborate explanation for it. Your max characters is 10. But now you can go into these external faults and give them actual names so that your operator knows exactly what's faulting, or giving them some type of error with it instead of it just saying some external fault. That's the power of Simicode. There's so much more, guys. Just to wrap this up, I truly appreciate your time, and I truly appreciate all that you have of taking your time out of your busy schedule to be with me. There are starter kits for the Simicode. There are a lot of things that we can do. My job is to help with you guys in the world of Simicode, and to help you guys with anything that you want to do down the road. Please, by all means, reach out to Heitek, and we can definitely come and give a little bit more in-depth training. I've kind of gone about 10,000 foot. There's a lot more I can go into. And in addition, I have all the demo equipment and computers available to where we could come and do a local training with your facility. I don't see any questions right now. If you have anything, please feel free to reach out to me. My name again is Mark Berger. I'm with Siemens, and I want to say thank you for everything. I'm going to stay online for a little bit if somebody has some questions, and then we will shut it off here in just a few minutes. Thank you again for all your time, and appreciate you guys attending this webinar today. I hope this was insightful, and again, we're eager to look at your applications. Thank you again.